Hello, this is permutation and combination lesson 4. In this I will discuss what exactly meaning the permutation, basics of permutation, that is plus quotients. Now I will explain this with the help of example that I have written. First of all, let me tell you what is exactly the meaning of permutation and how it is different from combination. When I say this permutation, it means selection and arrangement. Selection and arrangement. First you have to select, then you have to arrange. Whereas combination was only selection. That is the basic difference between permutation and combination. Let me explain this with the help of an example. This example says that in how many ways 3 boys out of 5 boys can sit on 3 chairs, such that exactly 1 boy sit on 1 chair. One of the methods to solve this question is fundamental principle of counting. This first seat, this dot, how many boys can come on this first seat? 5 boys. This seat can be filled in any of the 5 boys. So let's say one of the boys came here, boy number E. Total boys, I am assuming that there are 5, A, B, C, D and E. Let's say in one of the possible cases A sit on this place. Now for second seat, any of the 4 boys can come. This place can be filled in 4 ways. Let's say D came here. And then third seat can be filled with any of the 3 boys. Let's say B came here, this is 3. So answer is 60 ways we can 3 boys can sit on 3 chairs out of 5 boys. Now this can be solved with the help of permutation, that is selection and arrangement. Can I say I have 3 chairs, these 3 chairs. Now 3 chairs can be filled in only 3 boys at one point of time. At any one point of time there will be 3 boys who will sit on these 3 chairs, but I have 5 boys. So what I will do, I will first select 3 boys who will sit on these 3 chairs. In how many ways I can select? So let me first write selection and arrangement. I told you that permutation is selection and arrangement. So I will first select 3 boys who will sit on these 3 chairs out of 5 boys. In how many ways I can select 3 boys out of 5? Can I say 5 C 3 ways? I can select 3 boys out of 5 who will sit on these 3 chairs. Let's say one of the possible selection is A, D and E. There will be so many possible selections, that is 5C 3 ways of selecting 3 out of 5. Let's say I am taking one of the selection as A, D, E, one of the possible selection. Now these 3 boys can sit on these 3 chairs in how many ways? 3 factorial ways. How so? Because on first chair, this can be filled in any of the 3 ways. A, D or E can sit. So this can be filled in 3 ways. Let's say D sit on this chair in one of the possible cases. Now second chair can be filled with any of the 2 boys, A or E. Let's say A came here, this was 2 ways, and then last person E will come on this place. So 3 factorial. So can I say arrangement of 3 boys on 3 chairs would be 3 factorial. So very simple. When I say permutation, it means selection and arrangement. So first we have to select 3 persons out of 5 persons who will sit on these 3 chairs. Then 3 students can be arranged on 3 chairs in 3 factorial ways. So that is the meaning of permutation. So permutation is selection and arrangement. So how the formula will be formed? Can I say 5C3 into 3 factorial? That will become 5P3. Generalize this case. Can I say NCR, where R is less than equals to N, into R factorial will be equals to NPR. This is a formula for permutation. NCR into R factorial will be NPR. What is NPR? This will be equals to N factorial upon N minus R factorial. This is the formula for NPR that will become, because now you can see that if you open this R, this will be N factorial N minus R factorial into r factorial. This product is r factorial. Can I say this and this will be cancelled? This is what I left with. So can I say left hand side is equals to right hand side? So very important, NCR into r factorial is equals to NPR. That is the formula of combination. Here you will find the relation between permutation and combination. This P means permutation, that is selection and arrangement. This C means only selection. So there you can find the relation, that is NPR, that is permutation of r things out of n different things. This is selection and arrangement. First select r things, then arrange r things, NCR. This is permutation, this is selection and arrangement. This C means only selection only. That is the meaning of that's the relation between permutation and combination. So very important, if you want to find the permutation, that is selection and arrangement of r things out of n different things. So first select r, then arrange r out of r. So let's solve some question that will make the concept of permutation more clear to you. Question 1 is, in how many ways 5 boys and 3 girls can sit on 4 chairs such that exactly 1 person sit on 1 chair? So I have 4 chairs only, but the number of persons are 8. In how many ways these 8 persons, that is 5 boys and 3 girls, can sit on 4 chairs? So what I will do, I will first select the 4 person who will sit on these 4 chairs. In how many ways I can do that? I can do that in 8C 4 ways. In 8C 4 ways, I will first select 4 persons out of 8 in 8C 4 ways. Now I have selected 4 persons. Now I will arrange those 4 persons on 4 chairs. These 4 persons, let's say P, Q, R and S, they have selected out of 8. These 4 persons can be arranged on 4 seats, these 4 chairs, in 4 factorial ways. So that will be my final answer. Either the answer will be in this form, or you know that NCR into R factorial is NPR. This is also equals to 8P4. So answer will either be in the C form or P form. Whatever form, you have to mark the correct answer. So this kind of question can be solved in 20 seconds in exam. Second question is, in a rail route between 2 stations P and Q, there are exactly 10 stations. This is P and Q. 10 stations are in between. Station number 1, 2, 3 and so on. It would be 9 or 10. Now how many different types of tickets are to be printed so that passenger can travel from any one station to any other station? Now any one passenger can demand ticket from, let's say, station number 1 to station number 10, or vice versa. It could be station number 10 to station number 1, station number P to station number 9, station number Q to station number 11 and so on. So what I can conclude that for every passenger he will use how many stations for one journey. He may need a ticket from S1 to S10. He may need ticket from S10 to S1. He may need ticket from P to S9, or from so many possibilities are there. So how many possibilities are there? First we will need to find this. How we will apply that logic? Every person at a time for one journey will use 2 stations. Every person, you can see that, will use 2 stations. Either, as I have shown this, either he will use S1 to S10, S10 to S1, P and S9, Q and S11. Every person for one journey at any particular time will use only 2 stations. Now which 2 stations? First question comes, which 2 stations? So we will select 2 station. How many ways we can select 2 station out of 12 station? Can I say that 2 station out of 12 different station can be selected in 12C 2 ways? And this 12C 2 ways include all possible types of 2 station. This 12C 2 ways include all possible types of 2 station. Let's say one of the selection is station number 10 and P. Now, how many tickets we need to print? That was the question. Now, in one of the possible selection, that is S10 and P, the person may require ticket from S10 to P, or he may require the ticket from P to S10. So for every possible selection of 2 station, 2 tickets need to be printed. One ticket could be from S10 to P, other ticket will be from P to S10, station number 10. So for every possible selection of 2 station, we need to print 2 tickets. So for that many selection, we need to print this into 2. That is, the 12C2 is 66 into 2, 132 tickets should be printed. So that this will include every possible ticket from any station to every other station. So that is simple logic. This question can be solved in exam in around, let's say, 20-30 seconds. What you have to do, because every person will use 2 station, that is one for entry, one for exit. So 2 station out of 12 station can be selected in 12C 2 ways. This include all possible types of selection of 2 station out of 12. Now let's suppose that one possible selection is station number 10 and P. Now how many tickets one railway need to print? 2 tickets, one from station 10 to P and other from P to station number 10. So for every selection of 2 station, we need to print 2 tickets. So for 66 selections, we need to print 132 tickets. This will cover all possible types of ticket from any one station to every other station. That was all about permutation and combination lesson 4, permutation basics, with 2 questions I have discussed. Thank you.